Hi, today I'm going to be talking about Standard 31, which is graphing standards of 6 circular functions, and my name is Hadley Nelson. So the 6 circular functions that you need to know are sine, cosine, tangent, secant, cosecant, and cotangent. So as you can see right here, this is what a basis wave for sine looks like. Sine is the red line. And sine starts at 0, and it goes from 0 to 2 pi, and it crosses the x-axis twice at pi and 2 pi. And then the green line is cosine. Cosine starts at 1, and it crosses the x-axis 2 times at pi over 2 and 3 pi over 2. And for both of these, from 0 to 2 pi is one full graphing of the unit circle. So now we have tangent and cotangent, and tangent is the function graph on the left. And the tangent graph goes from left to right, and its asymptotes are at negative pi over 2 and pi over 2. And cotangent is the reciprocal of tangent. It's 1 over tangent. And the graph goes from right to left, and the asymptotes are at 0 and pi, and 0 and negative pi for cotangent. So for the cosecant function graph, it's the reciprocal of sine. So cosecant is 1 over sine. Its asymptotes are at 0 and pi, and then 0 and negative pi. And then for secant, its reciprocal is cosine. It's 1 over cosine, and its asymptotes are negative pi over 2 and pi over 2. And it's also important that if you graph either or of these functions equal counterparts, so if you have secant and you graph cosine and it's the same, but the cosine is just changed, or the function is just changed, the two graphs should intertwine, so the minimum and the maximum of the secant graphs should connect to the minimum and the maximum of the cosine graphs, and so forth with the cosecant. So now there's a few terms that we need to know when you're graphing these. So there's amplitude, which is the white number before the function, and it's always going to be there. And amplitude is the amount the wave goes up and down from the baseline. So wherever the baseline is, it's typically 0, but it can change, as this photo you see right here. Whatever the baseline is, and you say your number is 3, your amplitude is 3, that means that the wave is going to go up 3 and then down 3 from the baseline. So for example, at this photo right here, you see that the baseline is 2, and that this amplitude goes up 2 and then down 2. So that means that our amplitude is 2. So then we have the phase shift, and it's this pink number right here. And in the parentheses, if this phase shift, for example, as you can see right here, is negative pi over 2, that means that rather it's going to move to the right pi over 2. And a positive pi over 2 would move to the left pi over 2. So the phase shift moves the wave or function along the x-axis. So each point is going to move over a certain amount. So say it's to the right pi over 2, each point is going to move over to the right pi over 2, and the whole graph will shift. And then we have vertical shift, which is what changes the baseline. It's outside the parentheses, so its sign is the same as it is. So plus 1, that means that baseline is now at 1, and technically it's 0. And then we have the period. And the period is one full graphing of the unit circle. However, if it changes, that means that with whatever new number that the period is, that's the space that one full graphing of the period fits, and then it still goes into the normal graphing. So for cosine and sine, I have a formula to find the period, because as you can see, usually there's a number in front of theta. So for example, 2, and that's the number is the representative of k. So for example, you would plug 2 pi in, and then you would find k, which is 2, and so that means that our period would be 2. But for the tangent and cotangent, the equation's a little different. It's just pi over k, so you would just plug in 2, and your period would be pi over 2. So now we're going to graph a couple. So given the amplitude, period, phase shift, phase shift and vertical shift, create a sine function and then graph a function. So the easiest thing to do is the amplitude. We know it's the number before the function, so it's going to be y equals 3 sine. And then we need to do the period, because that's the number before theta. So we can do something like this. Since we don't know what k is, but we know what everything is, we can find out that k equals 2. So we have y equals 3, then we have 2, and then we have a theta, and then our phase shift is positive pi over 2, so that means we're going to move to the right, so it'll be minus pi over 2, and then we end our parentheses, and then the vertical shift is a positive 1, so that means we're going to go up 1, so we do plus 1. So our function should look something like this, and now we're going to go graph this. So the first thing we're going to do is look at, oopsies, where is that? Oh, well, I don't have one, but okay. We're going to look at what the basis sine graph looks like, and it looks something like this. It goes from 0 to 2 pi, which is right here. That's one full graphing of the unit circle. It crosses at pi and 2 pi. And the next thing we need to do is put in the amplitude, which is 3, so it's just going to take all these points that are 1 and negative 1 and make them 3 and negative 3, so something like this. And then we're going to take the period, and as I said before, our period is pi, so that means that everything we have from 0 to 2 pi is now going to be fit into pi. So for example, this half point, which right here is pi, is now going to be pi over 2, and this half of the half point, which is pi over 2, is now actually going to be pi over 4, and so forth. All these points are going to be condensed into pi. So it should look something like this. Yep, so this right here has moved to here, this right here has moved to here, this right here has moved to here, and then we have this all fit in to 2 pi again. Alright, so next we're going to put in the phase shift, and the phase shift just moves everything to the right pi over 2, so let's pull up this baby again. This point right here, which is pi over 2, 0, is now going to be pi 0 is going to become 3 pi over 2, and it should look something like this. And now the last thing we need to do is the vertical shift, and the vertical shift is plus 1, so that means our baseline is now going to be here at 1. And that's pretty easy. It just changes the point at which the minimum and the maximum is, so it's now going to be 4 and negative 2, not 3 and negative 3. So this is what our final graphing looks like. And that one's good. Alright. So the next problem we have is given the function below, answer questions A through D. So what is the amplitude, what is the period, what is the phase shift, and then we need to graph the function. So the amplitude is the easiest one. It's the number before the function, so that's 2. And then when we look at the parentheses, we actually see that we can simplify. So that's the first thing we need to do before we find the period or the phase shift. So we can take 2 out, and that means that in our new parentheses, we're going to have theta plus pi over 4. So that means that our period, so we still have the k is still 2, it's just outside the parentheses. And that means we're going to plug it into the equation, so 2 pi over 2, that means our period is going to be 2, or pi. And then our phase shift, so since it's in the parentheses, we know that it's going to be the opposite, so it's moving to the left pi over 4. So it should be negative pi over 4. And now we're going to graph a function. So now we're going to look at this problem. So given the function below, answer questions A through D. So the first one we need to know is the amplitude, and that's easy because it's the number before the function, so it's 2. And our period is pi. And then what is our phase shift? Our phase shift, so we can simplify this in here, and we can get rid of the 2, and it will actually look like something like this. Oopsies. So that means that our phase shift is going to be negative pi over 4. So now we're going to go graph the function, and first thing we need to look at is this just regular cosine function or graph. It goes from 0 to 2 pi, that's one full graphing in the unit circle, and it crosses the x-axis at pi over 2 and 3 pi over 2. So then we do the amplitude. It takes all the points that are 1 and negative 1 and makes them 2 and negative 2. Then we put the period, which puts everything from 2 pi to 0 into pi, so it looks like this. And then we're going to do our phase shift, which is negative pi over 4, so it's moving everything to the left. And it looks something like this. So, well, for example, it's going to take pi over 4, 0, and make that 0, 0, and it's going to take 3 pi over 4 and move that over. So it looks something like this. So remember, pi over 4 is now 0, 0, and 3 pi over 4 is now pi over 2. And then the last thing we need to do is the vertical shift, and it's outside the parentheses, so the sign is the same as what it's meaning. So that means we're going to move down 1. So our amplitude stays the same, it just changes the points at which our minimum and maximum are at. So it's now 1 and -3. So this is what our final graph should look like. Alright. So the next problem we have is graph the function f of x equals 2 cosecant theta plus pi over 2. So the first thing we want to do for this one is just graph what a normal cosecant graph looks like, and this is it. The functions, or the asymptotes, are at 0, pi, and 0, and -pi. And then we plug in our amplitude, and our amplitude for these graphs right here, for the cosecant and the secant graphs, just changes the minimum and maximum, so it's kind of the same, it just looks a little bit different. So these points that are now 1 and -1 are actually become 2 and -2, something like this. Yep, so that's what it looks like. And now we're going to do the phase shift. So the phase shift is just going to move all these points right here to the left pi over 2. So this point right here, which is pi over 2, 2, is now going to become 0, 2. This point right here, which is negative pi over 2, -2, is now going to be pi -2, so it looks something like this. So this is the final graphing of our problem. As you can see, the point that was pi over 2, 2 is now 0, 2, and so forth. They're all moved to the left. Yeah, so this is the final graphing. So now we're going to do our next problem, which is graph f of x equals tangent theta minus pi over 2. So again, the first thing we want to do is look at what the regular graphing of tangent looks like. So ignore that. So remember, it goes from left to right. The asymptotes are at negative pi over 2 and pi over 2. And since there's no amplitude, which would shrink or extend this graph, we just have to do the phase shift. So we're moving everything to the right pi over 2 because it's inside the parentheses and it's doing the opposite of what it says. So this point, which is 0, 0, is now going to be pi over 2, 0. And so forth, all these points are going to move to the right pi over 2. So it looks something like this. Yep, so this point 0, 0 is now over here, pi over 2, 0. Pi is now 3 pi over 2, 0, and so forth. So this is the final graphing of this problem. And now we have to do our last problem, which is graph the function f of x equals 3 secant. So the first thing we do for this one is we graph what the baseline for secant looks like. It looks something like this. So as you can see, these points, the asymptotes are at negative pi over 2 and pi over 2. It goes from 1 to -1. And the only thing we have to do is plug in the amplitude for this. And so we know that the amplitude changes the minimum and the maximum of these numbers. So once we plug in 3, these points, which are 0, 1, pi -1, and negative pi -1, are now become 0, 3, pi -3, negative pi -3. So it should look something like this. Yep. And so that's our final graph. As you can see, this graph is just shifted along the y-axis. So it's now 3, -3, -3. So that's our final problem. We're now done talking about Standard 31. I hope you got something from this. Thank you.